buddy gave me some whole bunch of flyback boards recently. One of the first things I ever played with in electronics was a flyback, and somebody pointed me to a basic flyback driver. I can't really remember what I did, but I'm pretty sure I just took something like this and I wound a primary and a feedback coil with a single 2N3055. I never really got an amazing arc from it, but it was also able to run from very low power, and I'm pretty sure that's because there was a very low duty cycle, and I wasn't really pushing a whole lot of power into it, but I was still able to get decent length sparks from it, but just plain sparks, no real super high current plasma or anything like that. And I've got another one right here which was a little larger, so this was the biggest one out of the bunch that I had, and this is basically just inside here is just that flyback, and it's wired to a 4N60 MOSFET is actually what's in here right now. All these other ones are more or less about the same, and I'm driving them all from this nifty little unit that I prefer to use rather than building a driver circuit right now, which is the square wave output, adjustable frequency, and duty cycle. This one right here has a capacitor on the primary. This one does not. And this one, actually, I'm confusing. This is actually 2 in series, so that's what I wanted to say. This is 2 in series, and those are about the size of that one down there, whereas that one is larger. And I only say that because by using this one larger flyback, I get pretty comparable output. The way this one is wired is I've just wrapped a primary around each of the flybacks, and I've put those primaries in parallel, and I've put the secondaries in series. Little resistor on there fried almost immediately. As soon as I turned it on, it's kind of interesting how that works. I mean, I guess obviously just the hair thin wire comprising that resistance in there couldn't handle it. Nice try, Nichrome. That sucker is just a toasting. So now it's just arcing, bypassing the actual where the wire used to be. But it's still holding on by that piece of, I don't know, what is that, ceramic? I don't know, it's about fried now. Sucker is getting hot. Now you can really see that plasma. Unfortunately, the underside, on the underside there, it's a little closer together, so it's actually, it's not quite arcing, but it's juicing over. But yeah, it sort of gives you an idea of the wind you can get off that. It's pretty gnarly. Here's a little electrostatic motor I made a while back, and it's a pretty good little usage for these flybacks, I think, aside from drawing sweet arcs. 3.1 volts, and let me see if we cut it on. That's about where this thing will start going. So actually, let me cut it off and bring it back down to about, so it all the way down to 1 volt, cut it on. There's a slight little something going on, but the way this is designed, it's not very efficient. It's very thrown together. I'm lucky it spins at all. As I cut it up, there's going to be a point where I hear that sort of that corona just going. Maybe you can hear it. So before it actually draws and discharges through a spark, you can really hear it. So we're at about 3 volts. So it takes about 300 milliamps to get to that point for this motor. And then once I get it going, start rotating. Here, it's still sparking and discharging away. But that's that's pretty cool. 3 volts. This is a series flyback there. Plus, I'm not. I've got a separate powered gate driver here, which is just battery operated. So whatever, no big deal. But yeah, it gets going. Pretty cool. I mean, I can try to back it down to the point where it doesn't really want to arc anymore, spark over. You get this nice little rotation there. It's got a cool little sound it makes. It's almost like a pulse motor noise, but sometimes it's cool to get it going. Let me see. Let me put that about 8 volts. I'm gonna crank the voltage up to the point where it just starts arcing over. I almost want to say at that point it might be operating off of ion wind. It's really hard to tell. Maybe that's the whole premise to begin with, but not really. But I'm telling you, I can just hear that wind whipping around so much that gotta be something going on. Touch the top there, feel a nice little spark, nice little shock. Yeah, I put this paper here so maybe you can see the dancing of the charge. Definitely a lot of charge going on here. A lot of charge. Yeah, it still go. Makes a lot of noise. Cut it up even more. Little mini Jacob's ladder action. So you Man, so I've been on the ZVS driver journey, and I started off feeling pretty comfortable because I had pulled about 8 of these power MOSFETs from a TV board, and while they weren't perfectly up to spec with IRFP 4232, they didn't quite have a low enough RDS, but they were high voltage, handle a lot of current. So I was hoping I could just throw them on 2 super beefy heat sinks, throw the components on, and well, bam, I'd be pulling some great arcs. But for some reason, I had a lot of trouble with these, and I burned them all out, and I'm not quite sure what I was doing early on. But one thing to notice here with this setup is it started off nice and clean and pretty, and now it's just a smorgasbord of clusterfuckery because the main thing is I ran out of solder. Never went and got any. I was too impatient. MOSFETs I'm using SUP 85N115s. Pretty low RDS on them, and they'll take 150. And since I don't really, at least at the moment, have a way of cranking more than 20 volts or so, and I don't want to do that anyway because I don't have Zeners on here, that'll be fine. But they can take the current 180 amps pulsed. So realistically, these are not going to get hot The only thing that actually does get hot on the circuit is the inductor. What I'm going to do is first, I'm going to cut this guy on, and I've got this is the 5 amp power supply. I've got, Jesus, can't even, let me turn that down. So this is my 5 amp supply. That's the max I'm going to get out of it, but at least I'm able to see that it will indeed work. Before, I knew there was just nothing, I tried a drill battery, I tried different things, it wasn't going to go. And now I can tell with this particular setup, it's going to do what I want it to do. So there goes the wave. 7.5 volts, about half an amp. Powerful little arc there. And what it's doing is, as I'm pulling that arc, it's drawing closer to a couple amps. Okay, so I'm going to crank that up some more. Let's bring it to about 9 volts. Start drawing it again. So now the arc is much stronger. And I'm still only pulling about 2.5 amps there. So, well, about 17 volts, about 17 watts right now. Just idling it. And I'm going to pull some arcs for a little bit, just to run it for a little while. Hot arc. Just show the power supply when I'm drawing the arc. That's what's pretty cool about this circuit, though. When I'm not pulling an arc, it pulls about an amp. There we go. Definitely the tiny little geometry of the shape of that copper cut on the end does sort of kind of steer the direction it goes in. Although it does sort of seem to want to lean to the right, probably because that's where most of the charge wants to go to in that wire. Yeah, look how red hot it's getting when I do this. Probably won't survive too long doing that, but like I say, bring it down below, instantly starts cooling down because all that heat can rise. So in my opinion, that's just showing the amazing amount of actual heat exuding from that arc right there. If you was to hold your hand just over the arc, you'd feel the amount of heat there. It's like a flame. It's literally like a flame. And I guess that's pretty much what it is scientifically. This bell wire here, copper bell wire I've got, holds up pretty well. Gotten kind of crusty. Holds up pretty well. The tiny nichrome wire in this resistor, though, not so much. This one's actually holding up better than the last resistor I threw on there. It burned out immediately. And it was working across the ends. Here's another ZVS I just threw together that I wanted to see what just random MOSFETs would do, what the real difference was. Now, first of all, these are sort of random components I've got that aren't really up to the proper values, and it still runs. You know, it's obviously not going to run as efficient as it can, but these MOSFETs, I'm pretty much down to the bottom of the barrel here, and if I actually had any better ones, I'd use them. But these particular ones, right here, there's 60R 3360P, or 60R 360P. The RDS isn't quite, I mean, it's just barely a little too high for this application, but it can take the voltage, 600 volts. So I'm hoping these don't crap out on the inside like the other ones. A lot of these other ones I was playing with. But one thing to note is these two chokes here that I just happen to have a pair of are way higher in value than they need to be. But I just kind of wanted to show what the operation was, and at sub 20 volts this thing is nothing spectacular, but at least it can handle, at least these can handle over 20 volts on the gate, so that's the good thing. But let's see here, I'm gonna slap the positive on here real quick. Positive. So it's only pulling you know, about 1.5 amps at 20 volts with this little arc here. And see if I can pull it out a little bit. I mean, it's nothing spectacular. A decent little arc, very high frequency. It's got a good amount of little current in it, but you know, I'm maxing out at about 2 amps or so, drawing that arc. It's really the caps and the inductors here are what's doing the magic. I mean, otherwise you just got like a basic push-pull. So if you don't, if your main choke or your two chokes, the way I'm driving this with just the two outputs, no center tap, if those aren't really working in unison with the primary and the caps, you don't have nothing special going on. So I'm going to play around with those a little bit to see what I get, matching those a little more, but these are not matched at all. And this is the performance that it is. So, I mean, you know,